Hello students, welcome back. In the previous videos, we talked about the meaning of the definite integral using the graphical interpretation, kind of like this. And then some estimation using, again, the graphical interpretation, kind of like these. And then we talked about how to use the fundamental theorem of calculus to find out the precise value of the definite integral, kind of like these. Find out the antiderivative, and then remember this bracket notation, plug in the top, plug in the bottom, subtract one from the other. The same deal here. Find out the antiderivative, plug in the top, plug in the bottom, subtract one from the other. This is capital F of B, that's capital F of A, subtract one from the other. Same kind of computation. Plug in the top, plug in the bottom, subtract one from the other. Now let's look at some other aspects of the definite integral. How about something like this? Now, is it possible to find out this value using the fundamental theorem? In other words, is it possible to find out the antiderivative of this? Well, that's not going to be possible. It's way too complicated. Still, it is possible to find out the value of the definite integral precisely using some other aspect, especially in this case, symmetry. Please note that this function is an odd function. X squared is even, and this is even function, so add up, so that's even, and sine of x, that's an odd function. More precisely speaking, I'm talking about something like this. Let me name f of x as this one, the integrand. Then, please note that f of negative x is equal to negative of f of x. The detail is left to the students. And sine function will have negative sign, and everything else will just stay as positive. So we have positive times negative. So it's an odd function here. And consequently, the graph is symmetric with respect to the x-axis, and consequently, this is just 0. Now, do I have a picture here? Okay, here's a picture. Plus, minus, they cancel each other out because of the symmetry. And if we have the picture, it's easy. Even if we don't have the picture, from this expression, you can see that this is an odd function, and then you can deduce the function value. It's a little bit unusual, but that's something that we can do. Another problem, this time we use geometry. What is square root of 4 minus x squared? What's that function? As a matter of fact, this is part of the circle. So what do? We simply calculate the area of the circle, area of the semicircle as a matter of fact, and here we go. 1/2 of pi r squared, and then you get the signed area, which is the definite integral. How about a problem like this? Oh, this is a little bit more interesting. Absolute value. Is there any kind of derivative rule regarding absolute value? No, there is none, because absolute value function is not differentiable. So there's no derivative rule or antiderivative rule regarding absolute value. So you have to find out a little bit more clever way to do that. And the best way is to use graph. Here you go. The red is the graph of the absolute value of the sine of x. So the red is, let's see, let me put over here. Y is equals to absolute value of sine of x. Okay, this is red. And then this one is light blue. As you can see, this light blue part goes down below the x-axis, but up to 0 to pi the same, and pi to 3 pi over 2, as a matter of fact, absolute value of sine of x becomes negative of sine of x. Maybe, yeah, better expression is over here. This absolute value of sine of x is equal to sine of x, as you see in this graph. So from 0 to pi, no problem there. And from pi to 3 pi over 2 over here, down here, when we have this opposite sign, the sine of x in absolute value is actually negative of sine of x. So you can calculate this integral and that integral separately using the fundamental theorem, like this. And then plug in the top, plug in the bottom, subtract one from the other separately, and then calculate. This is what we get. If you just used the fundamental theorem without absolute value, you're going to get 1, and that's not right. How to deal with absolute value? Basically, you'll have to cut off the interval and then calculate separately. By the way, this kind of problem is covered both by Calc 1 and Calc 2, and the majority of the absolute value problem will be covered in Calculus 2, but some part show up in Calculus 1. It's kind of in between, the gray area. For that reason, I don't write absolute value problem very often in a final exam, but in the homeworks I usually do, because after all, absolute values are covered in Calc 1 as well. Okay, what other aspect do we have to talk about? We have to talk about definite integral and the derivative. Do we have enough time? I think not. So let me stop here. This video is getting a bit too short, but it's okay. Let's stop here, and then let's discuss the other aspect in a separate video.